Riverside project. You can see over there. And this week we are on site and we are casting some footings. We got a lot to talk about right here before the concrete goes in. So let's take a walk over. These aren't your traditional footing forms. Traditionally, you'd see, 2x10s, 2x12s lining the footing, 2 foot on center. The steel dogs would go across there. But in this project here, the concrete guy is using a product called Fast Footing by Fabform. And basically what it is this kind of heavy duty bag liner that basically you attach these 2x6s. They get steel stakes driven in. Then they get nice and level all across, which is pretty easy to do, because then you just screw that in to the 2x6. 2x6 is nice and level. And then you can see here, it just simply stapled to that 2x6. And it's a pretty sturdy, you're not tearing that very easily. And it comes with preformed corners. So that all gets made up, set on top of it. And basically you have this kind of bagged flume here that is ready to accept the concrete. But we didn't stop there. We have our rebar in there, and standard nomenclature you can see here, these are rebar chairs. And the reason for the rebar chairs is basically to get the rebar off of the bottom of the form. The rebar handles all of the tensile forces or tension forces in the concrete. Concrete's really good in compression. Where it isn't good is when you put concrete in bending and you put tension on one side of the footing. So here, when the load is applied to the top, the footing wants to bend like this at the bottom. So we need to reinforce the bottom of the footing, and you do that by inserting this steel. But the reinforcement really doesn't work unless I get the rebar fully encapsulated in the concrete. Now, you can see here, close inspection, see how that rebar has kind of a knurled edge to it. Well, that's not by mistake or because it's the easiest way to fabricate it. It basically increases the surface area of that dowel, and it gives edges to the concrete. So as the concrete goes around it and cures, it basically grabs that. So you can imagine if that was a straight piece of rebar that was just finely milled, and we played a tug of war on it, you really wouldn't have anything to bite or grab. But by having that knurled edge, you could grab that and really apply some force in your tug of war. So now the important thing is not only getting it that couple inches above the bottom of the footing, but here at the corner, we need our rebar to be continuous. And you can see it's continuous there, but it laps here. And that lap goes all the way down to here. And believe it or not, that lap is specified in the drawings. And it's about 30 inches for a number 4 bar. And for number 5 bars, I think the structural engineer let us go down to 24. But you can see that here too. So you need that lapping so that the forces that are being applied to the bar here can be transferred to the bar in the corner, and then again transferred to the bar here that is running lateral. So if that lap joint didn't exist, or we simply butted it, then you would have a weak spot where the two butt, and at the risk of the concrete cracking. So that lapping is kind of bridging the area of concern, or the area where the bars end. So next up, we have what we call our J bars, and you can see those there. They have a bent leg down at the bottom, and you can see this one here. And as we go down, you notice that they alternate left and right. So they alternate so that you're not putting pressure on the wall in just one direction. or solving for just one direction, whether the wall wants to lean in or lean out. Here, it pretty much wants to lean in, but by alternating it, it gives us a nice consistent connection to the bottom of the footing. Now, here we use a product called Steel Mate. That's what these rebar holders are, and they basically just grab onto a 2x4, and you can see they create this little elevated support there, and basically run that 2x4 down, and then those steel mates just get screwed in to the top there, and then the rebar just basically snaps in. So once the concrete is cast, they'll pop this whole assembly off, and we'll just be left with that bar sticking out of the concrete footing, and we'll be able to tie that into our vertical reinforcement that runs up and down the wall system there. Next up is our steel dogs. So steel dogs are nothing more than these kind of frame displacement reinforcing bars here. They're steel. You can see they basically bite the 2x6 on each side. And what they do is they manage a consistent displacement of 2 feet, but they also, once we fill this with concrete, this footing is going to want to spread. So those steel dogs, in concert with these steel bars and spikes that are into the ground, hold that whole system together. And you can see those steel dogs there. So it's a little background on the footing. It looks like we have some fun here that just pulled up. You can see here. So it's your standard concrete pump truck, and we should be getting some concrete here soon, so stand by.